All right, so quick recap of Friday. If we've got an arithmetic sequence, it means what? Common difference, it means you're adding or subtracting the same number, right? So 1D is the common difference. 2, to find AN, we do A1 plus D times N minus 1. And what happens if we shift it? So let's say you're given A5 and you're given A10. God bless you. Actually, that's a bad example because those are going to produce the same, not the same, but similar. Okay, so yeah, sure. So which one goes on the left? Like if I want to bridge the gap between them. If I jump, I don't go from one to the other. How do I find the common difference? The A8 is going to equal A5 plus D times, which is 3. So the A8 would equal A5 plus 3D, right? So again, this number and this number, well, not that number, that number. This number and this number should add up to that number if you're doing arithmetic, okay? So the base on whatever it is you've got plus the number that the coefficient on D should add up to the base of the other number that you've got. So the bigger base goes on the left, smaller on the right, and then use the coefficient on D to bridge that gap. Yep.
So I have a question.
Okay, then we did geometric, and geometric, now we have R, which is the common ratio, and that's what's being multiplied by the terms to get the next term. Your AN is A1 times R to the N minus 1. And if we are given terms and we are skipping them and we want to find D, how do you do it? So let's say I'm given A5 and A8 again. Which one goes on the left? The bigger one, so A8 is going to go on the left. It's going to equal the smaller one, so A5 times R to what power? 3, not 4 minus 1, because we don't know what term it is, right? It's 3. This time, this plus this equals that. So in 2.2, we talk about the link between linear and exponential with arithmetic and geometric. So we talked about linear and exponential functions like in chapter 1, but now you're going to start to link these two together. So if you think about the actual overlap, the slope-intercept form of an equation is f of x equals mx plus b. And because order doesn't matter on addition, you can actually reverse that. And you could say it's b plus mx. And then on the right is your arithmetic sequence, which is starting value, so a constant, plus a rate of change times n. So these are the same, right? If I took A1 plus D times n minus 1, and I distributed, and I could combine these together because... Wait for it. If I combine those together, they're going to be a constant, which would produce that A0. That's where that comes from, okay? But either way, what this is basically saying is if I have an arithmetic sequence that starts at a point and increases by the same amount or decreases by the same amount, it's going to be almost the exact same thing as if I had a line and I had my slope-intercept form. In each of these, so if I look at the slope-intercept form, what's your initial value? Where do you start? At the y-intercept, which would be b. And we're waiting. For slope-intercept is b. If I use the arithmetic an equals a0 plus bn, what's the initial value on that one? A0. Good. So if this was an actual equation, it would say something like this. Let's make up numbers. 5 plus 3 times n. okay? All right, so again,
Then your
initial
initial value would
value
be 5,
on
correct.
a linear
And they
function
would-
would be
they-
the b or the
they're-
y-intercept. An initial value on arithmetic is gonna be that first term, the one that is not being multiplied by n, because that's your rate of change. So then your rate of change is like your slope, right? So your slope here is your rate of change for your linear function, and the rate of change here is your common difference, which is d. So they both have an initial value, they both have a rate of change. For geometric and exponential, these are very similar. So if I look at the actual function notation for an exponential function, it's a times b to the x. And then for your geometric sequence, it's a, they actually call that a naught, which is what the 0 is, times r to the n, okay? They also both have an initial point, so the initial point would be a. And then they have a rate of change, which is that b or the r, God bless you. The difference is it's exponential this time, so it's what you're raising to a power instead of having like something like slope. So with these, what you can actually get is coordinate points, because these are actually going to be points. They're not, well, exponential would have a fluid curve, but a geometric sequence is going to be dots. Where n, the x value is on the exponential function, it's your x value. And then you plug it in and you get the y value. Oh, I don't know why I just wrote that, because that's here. That's that. And then on the geometric sequence, what you plug in is the value, or not the value, the number of the term, so that's your n. And what you get out of it is your an. So they can both look very similar. The difference is this. On the left-hand side, your is your geometric. This one is your geometric. And this one is your exponential. And the same thing would happen with linear and arithmetic. Arithmetic and geometric are not a constant function. It's not a continuous one. It's discrete. They are individual points, okay? And then obviously exponential and linear are continuous. The domain of both these sequences, the domain of the sequences, the arithmetic and the geometric, are discrete points. They would be listed with commas. And the domain of exponential function and linear functions are negative infinity to positive infinity. It's like messing with me now. A change in output values, okay, over equal length input value intervals. If the output values of a function change at a constant rate, then the function is linear. Proportionally, then the function is exponential. Think about it in terms of arithmetic and geometric too. A constant rate means you're adding or subtracting the same thing every time. So it would be linear or arithmetic. And proportionally, meaning you're multiplying the same thing every time. That would be exponential or geometric. So it'll give you a function and it'll say, is it changing at a constant rate or proportionally? And then if so, determine if it's exponential or linear.
So arithmetic is like points.
Well, they're both points, arithmetic and geometric, is that what you mean? Arithmetic would be dots like this, whereas linear is going to be a line.
So what's the difference between geometric and
Geometric, you're multiplying by a number every time. Huh? No, they don't look the same. No, geometric has a shape. What? Geometric won't have a shape, a straight line. Yeah, correct. It's exponential. It has that curve. Yep. All right, example 1 says a function has the following coordinates. Could the function represent a linear, exponential function, or neither? So basically, the first thing that we're looking for is our change in x. It has to be constant, okay? So if I look at my change in x, I go from 2 to 3 and 3 to 4. They have to be over equal intervals, are they? Yes, they're all going up by 1. Then I compare my y values. Are they increasing by the same amount, being multiplied by the same amount, or neither? What's happening here?
Multiply by 4.
You're multiplying by 4, which would make this what?
Exponential.
Good.
Wait, so if it's both, it's exponential.
What do you mean if it's both?
Like you're adding and then
No, the adding means you're checking the interval. That has to be an equal interval in order to use those points. So that's just to say, can I use this to even determine it? Then you're looking at the y and seeing, are you adding or multiplying? That determines exponential or linear. So go to the next one. Look at my x's. I'm going up again by 1, so that's okay. Now I look at my y's. Am I increasing by the same? No. Am I multiplying by the same? No, right? So this isn't either. So I can do 7 minus 3 and 10 minus 7 to see if it's the same increase. And I can do 7 divided by 3 and 10 divided by 7 to see if it's the same proportion. All right, then you go to C. I'm going from 3 to 5 and 5 to 7. Is it the same interval? Yes, it's by 2s this time, but it's still the same interval. And then I'm going from -1 to 7, and then 7 to 15. You're adding 8 each time, which makes this linear.
I just know the difference between like exponential and.
All right, example 2. A says f of x is a linear function that passes through 3, -1, and 7, 15. Write an equation for this function. How do I write an equation for something that's linear? Y equals mx plus b, or if I wanted to do arithmetic, okay. Or if I want to stick to linear, point slope, y minus y1 equals m times x minus x1. So you can choose between those two. But in both cases, what do you need that you don't have yet? The slope, right? So how do I find the slope? y2 minus y1 over x2 minus x1, right? All right, so before I can find the equation, I have to find the slope, but I am given 2 points, so I can find that. I could do 15 minus a -1 over 7 minus 3, and I get 16 over 4, which is 4. So not only is that your slope, but it would also be, if this was arithmetic, right, it would also be your common difference, because you can kind of go back and forth between those two. All right, then I would plug it into either y equals mx plus b, or I would plug it into y minus y1 equals m times x minus x1, your choice. So I pick either point. I'm going to pick these because they're both positive. Y minus 15 equals m is 4 times x minus 7. Y minus 15 equals 4x minus 28. Add the 15, and y equals 4x minus 13. Questions? All right, B says f of x is an exponential function that passes through 2, 1, and 4, 16. Write the equation for this function. So I actually think it's easier to treat these like they're geometric than it is as exponential when we do this. I tend to use the geometric one, okay? So the first thing you have to do is go back to what we were doing at the beginning of the day. We don't have r. We don't know that rate, right? But if I treat the x as your n, and I treat the y as your an, then I have an n of 2. So the second term, and an n of 4, which means I can do a4 equals a2 times r to what power? The second power. Remember, those have to add up to be the one on the left. So if a4 is the y value that corresponds to it, and a2 is the y value that corresponds to it, then I end up with 16 equals this r squared. R would equal the square root of 16, which is 4. So now I have my r. And I can set up 2 different equations. One, I can really do 3 if I wanted to go that far. One where my first term is a2, or one where my first term is a4. I just have to adjust the exponent on it after. So if an equals a2, it would, a2, this would be r to the n minus 2. So I could say an equals a2, which is 1 times r to the n minus 2. or an equals 4n minus 2. Or I could say an equals a4, because that's the other one I have, to the r times, or raised to the n minus 4. So I can say an equals 16 times 4 to the n minus 4. So if it was open-ended, you could put either of those, and if it was multiple choice, or multiple answer, they both might be there. Or if it was multiple choice, you're only going to see one of those. If I wanted to go backwards to find my initial value, what would I do? Like, how do I find A1 if I have A2? You could plug it in. Or what? What am I doing to get the next one? Like, if I have A2, how do I get A3? If it's geometric. Mm-mm.
A to the 3, like A sub 3 equals.
How do I get consecutive terms if it's geometric?
You just do the formula.
Without a formula. Do you know R?
Oh, the top of it.
Do you know R? Multiply by 4. Yes? If I went from here to here, I'm multiplying by 4? Yeah? So if I wanted to go backwards, what do I have to do? Divide by 4. So if A2 is 1, what's A1? 1/4. Does that make sense? So another way to write this is an equals 1/4 times 4 to the n minus 1. That's your initial function. Yeah.
I'm confused how you go R.
I used the equation here to get R.
Like the green part.
Yeah. So you got given two terms. They were in disguised as points, but they are terms, right? If I had, because I had 2, 1, and I had 4, 16. This is my n, and this is my an. This is my n, and this is my an. So if my n is 2, then my A2 is 1. If my n is 4, then my A4 is 16. And then I plugged it into this equation.
So it doesn't matter which one you do.
What do you mean?
Like, because you know how you put A4 is equals.
When you find the end answer, it doesn't matter. Yep. You just have to adjust the exponent. Dane.
So do we have to write it in terms of y and x, or it's okay if we write a to the n?
You could have rewritten, like I could have said y. I actually think the answer says y equals 4 to the n minus 2, or y equals 16, 4 to the n minus 4. It might even say f of x, because all of those are the same thing. So if it's open-ended, you want to use y or f of x. If it's multiple choice, obviously look for it. I'm pretty sure the key says y on today's homework.
So all we gotta do is just know that for a n we can substitute y. And
Correct.
we can substitute x.
Correct. All right, this one says the following functions, here we get easy, right? Hopefully we wake up a little bit. The following functions are either linear or exponential. Identify the constant, either slope or ratio, that causes the output values to change. Is A linear or exponential? Linear. And what is your constant, slope, or ratio? -2. The slope is -2. I don't think so, but maybe. Yeah. What?
Is there somebody outside of that?
Okay. B, linear or exponential? Exponential. And is it a constant slope or constant ratio? Ratio. And that would be what? Which one has the x? That's the one that would be changing. You'd be 5 to the first, which is times 5. 5 to the second times 25, like that. Okay, so you're looking for the one that's being raised to the power. Good? It's back. I can hear. All right, now you get a table of values. Again, same kind of question as before, though. Determine whether the functions are linear or exponential. Justify your answer. So how would I know it's linear? If you're adding the same thing or a constant rate, right? How would I know it's exponential? You're multiplying the same thing or you're finding a ratio. So first you have to check to make sure these are on equal intervals. From 3 to 7 went up 4. From 7 to 11 we went up 4, so it is an interval. Now I go to the bottom. What's happening? You're subtracting 4. So is that a constant rate? Yes, this makes this linear because constant rate of -4. Okay. Something like that.
Wait, so what decides whether it's linear or exponential is the f of x?
Correct.
So the x is not.
The x has to be on an equal interval, but the actual decision comes from the changes in the f of x.
So what if it was like
Okay, b, so again, you're looking at the numerator, the x is first, they are increasing by 2, so we're good. Now I look at the bottom, what's happening? It's being multiplied by 3, so this is exponential with a ratio of 3. Or it is proportional so you will see that it has a common ratio, you will see it's being multiplied, you will see that it is proportional. All of those things mean that it's geometric, okay? If it's linear, it's a constant rate of change, it's a slope, that kind of stuff. So those are the words you're going to look for linear. Still good? Okay, example 5 says for an arithmetic sequence, Sn, S2 is 10 and S5 is 22. What's the value of S2 minus S9? Any ideas how to start it? Set up an equation for what?
what are the terms? S12 or whatever.
A single term, okay. There's like I think there's 2 different ways to do this that I can think of. But so if we're going to set up an equation for a term, this is my n, and that's my an, right? This is my n, and this is my an, if it was a5. I could do it that way. For linear, you could literally just do your rate of change. So it would be your change in the f of x, or in this case, the s, over the change in n. So I went from 22 minus 10 over my n is 5 minus 2. So I'm finding slope, right? Same kind of concept. Rate of change, slope, arithmetic, all of it, same concept. So this would be 12 over 3, and my rate of change is 4.
Wait, so S2 is the same thing as A2? And S5
Correct.
is the same thing as A5?
Correct. This would be D because it's arithmetic. Now, again, I can set up an equation or think about what's happening. I want to know from 9 to 12. So if my n is 9 and my n is 10 and my n is 11 and my n is 12, how many times am I going up by 4? 3 times. So no matter what those numbers are, this one would always be 4 bigger than this one would always be 4 bigger than this one, and this one would always be 4 bigger than this one, which means my rate of change is going to be what? Or what the value, sorry, of these two. I went up by 4, I went up by 4, I went up by 4. If I subtract them, 12. I did it 4 times. So it doesn't matter what number you picked. You could literally have picked any number there. Every time I went up by 4, if I subtract the bigger from the smaller, it would have been 12 because it's an increase of 4 each time. Okay? You could have also literally tried to figure out, like, you could have set up an equation. I could have said, let's use 2. A2, actually I had to use 5. A5 equals A2 plus 3D. I could have done A5 is 22, A2 is 10, 12 equals 3D, and D equals 4. And then I could have said if I want to find 12, I could say A12 equals, I could pick A5 or A2. If it's A5 plus, this would be 7 times D. A12 would equal 22 plus 7 times 4. 22 plus 28, which is 50. Right. So I could say A, what am I finding? A9 would equal A5 plus 4 times D. A5 is 22 plus 4 times 4. 22 plus 16. And then I can say 50 minus 38.
I mean, I feel like you can just say equations of an equation, just do the rest in your
Sure.
head. You don't have to like write it
You mean after you figure out the rate of change?
Yeah.
Yeah, like we did here.
out, because it's just simple multiplying.
Agreed. Yeah. If you understand it. So I could have done that whole thing instead of using A5s, I could have used A2. But if I was finding A12, I would have to do A2 plus what times D? 10 times D. And then if I wanted to find A9 and I start with A2, I have to add what? $70. Does that make sense? So if it's arithmetic, you're using the coefficient on D to bridge the gap. If it's geometric, it's the exponent on R that bridges that gap. Questions?
Can you zoom in
So this is like how, like there's more than one answer here, right? So first you have to do is actually figure out what your equation is with your, this is arithmetic, right? Because we're increasing by 4 each time. So D equals 4. So my original like parent one would be AN equals A1, which is 2, plus D, which is 4, times N minus 1. So I would have looked to see is that any of them, and it was this one. Then I would have distributed the 4, 2 plus 4N minus 4, and got negative 2 plus 4N. And if you look, or 4 plus 4N minus 2, that's also 1. That's this one. And then what happens if I shift A1, right? So if you look at the ones that are there, I shifted A1, like this obviously is going to give you a different answer. This is going to give you a different answer. But what happens if I use 10 as my initial one? 10 is in my range. 10 is the third term. So if I did A3, and I'm trying to find my AN, whatever it is, then my value here has to get shifted. I went from A1 to I went from A1. Oh, this would have had to have been 3. So it would have been plus 4 times N minus 3 in order to use that one. The other one was if A whatever was negative 6, if your term is negative 6, which is not in your set yet, but if I kept going backwards, if I did 2 minus 4, then I would have gotten negative 2. If I would have done negative 2 minus 4, I would have gotten negative 6. So this was 1. This would have been 0. This would have been negative 1. So my A negative 1 plus 4 times N, instead of adding 1 or subtracting 1, I'd actually have a negative 1, which is where A negative 1 plus 4N plus 1 comes from. And it's negative 6. To me, that was the trickiest one because you had to work backwards. But you have to see, can that value be in your arithmetic? And it is. It can be. You could either count it out or you could have plugged it in, but it could have been. You also could have like distributed all of them and seen if it gave you the same thing. Like if I just distribute this out, I'd get 4N minus 2. That matches, right? If I distribute this out, I get 4N minus 2, and that also matches. So if you simplify your equations, they all have to be the same. Does that make sense? Like if you look at your equations and you distribute your D,
I just didn't understand the last one.
maybe this is the easiest way to do it then. Maybe distributing that 4 and simplifying it to see if it gives you the same simplified version as here. Because that works too. Yeah.